All right, here's our video, Living Environment Regions, our 12th video, and we're talking about biochemical reactions, our first part one. And specifically, get our pen going like always, we're going to be talking about chemical reactions. Talk about chemical reactions and chemical formulas. All right, so we're going to be talking about, so what color should we use? Here's green. Press the green, there we go. So we're going to be talking about chemical reactions. All right, that is the first part. So let's get a clear page. So what is a chemical reaction? So let's say, for example, let's talk about something that's not a chemical reaction. Let's talk about a physical reaction. And we'll talk about chemical equations in a minute. So for example, let's say I'm drawing this ice cube. For some reason it's green. Well, so we have this ice cube, and we know that the ice cube is H2O. It's the hydrogen oxide. It's water. You know it's water. And if this ice cube melts, should use blue, right? People kind of symbolize water with blue. Why not? Even though it has no color. So when the ice cube melts, guess what? It's still H2O. So this was a physical change, right? And even if I, for example, let's say we'll make a little flame. That's a bad flame, but here's our little flame. If I, heat up this water, it'll turn into steam. And guess what? It's still H2O. It's still water. So it's still water in any state here. It's still water. So it's a physical change. Now, with a chemical change, put a little arrow down here. Now, we're going to take one or more substances, and I'll give examples. One or more substances, which, by the way, will be called the reactants. It's a vocabulary word there. The reactants, one or more substances, the reactants, are converted, or if it's one, is, right? They're converted to one or more different substances. Different substances. And those different substances, that is, are the products. So let's read it again. One or more substances, called the reactants, are converted to one or more different substances, the products. So hold that there for a second if you want to read it again, or you can rewind. All right, let's clear that out. So basically, when in a chemical reaction, the reactants will yield a product. And we'll talk about that symbol again. So that symbol right there you're seeing, that's the yield sign. Not the yield sign you see when you're driving, but it means it will, in other words, it's going to produce something new. That's in a chemical change. So let's look at examples of that. So, for example, there are, and let's list a few, right? There's photosynthesis, where the plants get their food, right? That is a chemical reaction. Rust, for example, is a chemical reaction. Combustion is a chemical reaction. Fire, for example. Burning of wood, we should say. The burning of wood, and we'll give an example of that in a minute. Burning wood. And, there's others, and let's say, and cellular respiration. We talked about this before in other videos, cellular respiration. We talked about it when we wanted to talk about how the body got glucose and ATP. So if you want to look at those other videos, so respiration. So these are examples of a chemical change, a chemical reaction. So, for an example, another thing you should know in these chemical reactions is a chemical formula. So, for example, let's talk about cellular respiration. Cellular respiration, right? So, for example, in cellular respiration, when the body had food, it has its glucose, which it wants. We talked about this in the other videos. Glucose plus oxygen in cellular respiration will produce CO2, which is carbon dioxide. Because remember, we take in oxygen, but we exhale carbon dioxide. We also exhale water. So let's look at this chemical. We'll look at a chemical equation. A chemical equation. All right, so for the glucose, for example, if you remember from last videos, it's 6 carbon molecules, then it has 12 hydrogen molecules, and then it has 6 oxygen molecules. Now, if you add that together with this, which is O2, this is, by the way, the number next to the element is called the coefficient, just like in math. So we'll put a little arrow to explain that. That is the coefficient. The coefficient. So all this is saying there are 6 O2 molecules, and O2 is just 2 oxygen. We breathe in O2. Remember, we breathe in O2, not just one oxygen element. So this is saying we have 6 of these O2s. This is saying that there's 6 carbons, there's 12 hydrogens, and there's 6 oxygen. So, but this is saying there's 6 of the O2. And I'll give more examples of that. And so it's going to yield, in cellular respiration, it's going to produce, that's the yield sign, it's going to produce, like we set up here, CO2 plus H2O plus water. And actually, it will produce 6 CO2s and 6 H2Os. Now, if you think of, and let me rewrite this so I can show you a reverse of this. Let's clear that out. So again, when we're talking about glucose, let's write it again, glucose, right? We need glucose. And we talked about this in other videos. Oxygen and glucose is going to yield carbon dioxide plus water. And the formula, again, like I said over here, we need carbon, 6 carbon molecules, 12 hydrogen molecules, and 6 oxygen. Plus, we need 6 of the O2, and that will yield 6 CO2 plus 6 H2O molecules. And this will be cellular respiration. Now, if I had, we'll change the color for green, photosynthesis, for example. We'll have other videos on photosynthesis. I'm sure you know photosynthesis is where plants make their own food because they're producers while we're consumers. So in photosynthesis, it's the exact opposite. So you're having 6 CO2 plus 6 H2O, make that O better, and that'll yield carbon, 6 carbon, 12 hydrogen, 6 oxygen, plus 6 O2. So you can see it's completely opposite. It's reverse. Now, something about this yield sign, you see it's going one way. We'll talk about what if it goes both ways. We'll talk about that in a minute. So we'll talk about the yield sign in a minute, more about when you get 2 arrows. Just basically with 2 arrows, it means you can reverse the situation. But over here, we have wood. So if we're burning wood, here's the formula for burning wood. Get our pen going again. right? So you can say it has the coefficient here. This is the coefficient of 2. It has 2 carbon, 6 carbon molecules. Also, this whole molecule here with 12 hydrogen and 6 oxygen, there's 2 of these. Plus it has 2 of this, Ca, plus 13 of this. And it will yield this, as you're seeing here. It will yield ash, carbon dioxide, water, and energy in the form of heat and light. Right? All right. And so when the wood becomes ash, it's a different substance. It's not wood anymore. And you can't take this ash and turn it back into wood. So it's a one-way change in this case. That's why the arrow is pointing only in one direction. So again, you have 2 of 6 carbon, 12 hydrogen, and 6 oxygen. Plus you have 2 of calcium. Remember, Ca is calcium. Plus 13 of the O2, and you get this. You get ash, right? You get carbon dioxide, water is released, and of course energy and heat and light. So let's give an example. Let's say, and get our pen going, use purple. Let's say we had, a molecule A plus a molecule B, or some element, and it produced C plus D, whatever these things are, just giving an example. Now, as you can see here, it's not reversible, it's one way. But if we had A plus B, and we had something that looks like this symbol, that means it's reversible. You can go the other way. That's reversible. And we'll talk more about this in other videos. Now, another example, let's say we had nitrogen. We had N2, so we had 2 nitrogen atoms here, right? And let's say we added it to 3 H2 molecules. By the way, remember, these are coefficients. There is a 1 here. So remember, in math, we don't have to put the 1. There is a 1 there. We just don't have to put it. So we're saying there's just 1 and 2, but you don't have to put the 1 there. And so what would this mean, this symbol? What do you think? It means whatever I'm making here is reversible. So it'll be 2 NH3. And this is ammonia. This is ammonia. Not pneumonia, ammonia, right? It's reversible. And one quick one. Let's say we took nitrogen again, 2 atoms of nitrogen and 2 of oxygen, O2. Remember, we breathe O2. And we had something like this, and we got 2 NO, right? And this is nitric oxide, and so forth. So 1 arrow means it can't be reversed. 2, it can be reversed, and we'll talk more about that in the next video. Now, one other thing we should know about is the law of conservation. So let's talk about that. Let's clear this out. The first thing and get our pen going there again. First thing we should know of is matter. Matter is anything that has mass. Anything that has mass and volume, right, is matter. And we think of matter as anything we can possibly see, anything we can see, we can feel, anything with our senses, from our little dog, from our book, to the window, to Aunt Sally, to cookies, anything you can actually see or sense, feel, touch is matter. And we think of it as everything in the universe, but it's not. It's only 5% of the universe. And we'll talk about other properties of, not properties, but there are other things in the universe like dark matter. I'm sure you heard about dark matter. But don't want to get too deep into this. And dark energy, for example. And dark energy makes majority of our universe. So we're only talking about what we know, and that's matter. And it has mass and it has volume. And what you've been taught in school is that here's one thing you've been taught, and I'll write it down, but it's not exactly true. Matter cannot be created nor destroyed, right? It just changes form, right? Well, this is not exactly true. But for our purposes here, the conservation of matter and the conservation of mass is saying that it will change form. So when we looked at the wood, right? If we took the wood and it became ash, it will retain the same mass. Energy was transferred from the wood to the ash, so the matter was not destroyed. But again, this concept here, I'll talk about in the next video a little more. All right. So in the next video, we'll talk more about chemical reactions, more examples, and we'll talk about this controversial topic here. All right. Great job.